All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. Riley Hawksworth, good to see you. How are you doing tonight? So, we are going to be picking up tonight where we left off last night in our sort of major 0.7 refactor that we've been working on. And hopefully, make some pretty decent progress tonight. That's the goal anyway. So we're going to be focusing on mostly the renderer refactor tonight, as well as the plugins. So that's kind of the goal tonight. I'm doing good, Riley. Thank you for asking. Appreciate that. So before I get into that, though, I do want to take a quick second and just thank the supporters of the channel, beginning with the partners. They are the top tier of subscription over on Patreon and YouTube memberships. They are Dustin Punt, Gabby Bashir, and Gerbullies Inc. I would also like to thank all of the other supporters listed here on the screen. They are a combination of the other forms of subscription, or the other levels of subscription, rather, on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me out a lot. I hope it goes without saying also that I appreciate each and every one of you viewers, whether you're here on the Twitch side or whether you're on the YouTube side. I'm pointing to different monitors here because we do simulcast to both. And so with that said, this is an interactive stream, so I encourage you to feel free to jump into chat. And if you have any questions or anything like that, feel free to ask. This is an interactive stream. It's designed to be an educational resource. So I like chatting with you guys, so feel free to jump in whenever you like. And I will do my best to answer any questions that you have. All right, so with that said, tonight we are going to focus, as I said, primarily on renderer stuff, more or less, in terms of refactoring our render system to not only work with our new plugins, but also to at least get some stuff in place for multi-window support. So I have gone ahead and done some stuff offline, and most of it's just minor, but there are a couple of things that I do want to actually point out that I was in the middle of that we're going to actually pick up from. Some important things to point out, more or less. So if we go to the Vulkan backend, this is probably going to be the best place to explain all of this stuff. So we have these new functions in here. So we have Vulkan render on window created and on window destroyed. And you'll note here that we have some logic in here where we've gone ahead and added in some state to the renderer window. We've actually changed the structure behind that a little bit as well. So there are essentially three tiers of window information. So actually, if I peek definition on this guy, or maybe I have to go to it. Okay, apparently my IntelliSense is not picking up the right thing. All right, that's fine. So we'll go to, let's see, I believe I put these in platform. So we go here to the top. Let's see, we have our K window. So this used to be a sort of opaque handle. And I actually changed away from that. We had some stuff in there. We were using sort of the address of the window pointer to do some lookups for internal state and stuff like that. I just decided that was too cumbersome. I'm going to treat this a bit like I have some other resources in the engine. So the window now is a actual exposed structure outside of the platform that holds its name and title. It may hold some other stateful information too, like position, things like that. Currently it does not. But it does hold a platform state. So this K window platform state, all that is the platform specific information. So on Windows, that's the WND, or the handle to the window. On Linux, there's an XCB handle to the window, and so forth, right? So that is stored in the platform state of the window. And then we also have this renderer state. And this renderer state is what is responsible for holding renderer specific information about the window, because there is going to be renderer specific information about that too. That, however, comes in 2 layers. So if we take a look at render types, and we go to, I believe it's right here, we'll see that we have type def'd out our structure for our renderer state, our window render state rather, right? And so that holds a pointer back to the main window just in case we need it for any reason. That's just a convenience pointer, right? It holds frame buffer information, so it holds the frame buffer width and height, and then it also holds the active viewport. This may or may not change. It holds the draw index. Again, this may or may not change. I'm going to try and get rid of that, actually. And then it holds the frame index, and that's the sort of image index, right? You can think of it that way, right? So if we have 3 swap chain images, that could be 0, 1, or 2, for example. And then we also have this structure to a K-window renderer backend state, right? And this is that 3rd tier of information I'm talking about. And so the reason we have this guy is to hold any Vulkan specific information, right? And so if we go to Vulkan types, and we take a look at the window backend state, we have made some changes here as well. So this is the renderer specific information, right? And this is in Vulkan type, so this is all Vulkan specific renderer information. There would be a version of this for DirectX, there would be a version of this for Metal eventually as well. So in here, what we're doing is, since the surface is directly associated with a window, it makes sense to keep the surface with the window. We also keep a swap chain for each window, right? So this is now not just one swap chain we could have multiples. The current image index is also kept with the window because that is directly tied to the swap chain images. The flag for recreating swap chain is also there. This render target, world render targets, I moved here as well. I don't actually think we're using this anymore, but I have to verify that, right? But the render targets essentially are also going to be they're also essentially going to be not referenced. What's the word I'm looking for? They're going to be owned by the window, all right? And then, of course, we have frame buffer width and height. Now, we do have this on the sort of front-end version of this, too, so I'm going to probably get rid of these two and just keep a reference to the front-end version of that. And then we have a frame buffer size generation, right? That goes along with that, and a frame buffer size last generation, right? So we've moved all of these things to be essentially coupled with a window because that's essentially what they were. We just didn't have it set up that way in code. And so that is kind of what we're doing to facilitate multi-window support. Now, I should mention that multi-window support is not going to be something that we're going to use right away or even fully implement, but I want the renderer to at least be capable of it. Okay. Linux has multiple display backends that handle windowing. How do you support them all? So right now, I'm only supporting X11. I do plan on writing a Wayland layer as well. And then, obviously, that's going to be completely different when we go to handle Android. That's also going to be different, right? So the concept of a window won't exist on that platform. It only really exists on desktop platforms, and so we'll have to come up with something that is generic enough to span between iOS and Android for mobile, right? Coffee Lava, good to see you, buddy. How are you doing? I haven't seen you stream in quite a while, actually. How have you been? I hope everything's okay. And welcome. Let's see. Do you have code snippets suggestions for Clang D? I looked at your dot files but couldn't make any sense of it. So code snippets or suggestions for Clang D in terms of like setup? Because there's like multiple parts of that, right? Because Clang D also uses these compile flags text, right? Which I generate as part of the build process. So that might be what you're missing too, right? This is what contains like include directories, any defines, things of that nature. Are you cross-compiling? So cross-compiling, do you mean like cross-platform compiling? If so, then yes. Yeah, we compile on Windows, Linux, and Mac OS at the moment. Like when you're typing and you type glfw, it gives you a bunch of that IntelliSense, like the code completion stuff. Yeah, I mean, it's just a combination of my Vim config and then also these compile flags give me a lot of that stuff too. So like in the Vulkan plugin, this might actually include some additional stuff. Although, unfortunately, because of all the moving around I've done, this doesn't build at the moment. And so not all of my compile flags are actually regenerating. So it's kind of broken at the moment while I'm in the middle of this large refactor. But yeah, at some point I could put together an article about exactly how I set it up. Maybe that might be useful. You're doing okay, Coffee? Okay, I'm glad to hear that. Yeah, I'm doing pretty well. Can't complain. I'm just working through a pretty large refactor at the moment. Basically trying to standardize structuring across all of my different plugins, and I'm also putting in like multi-window support and trying to do code cleanup and stuff like that. So I've kind of just like blown apart the whole code base, just trying to make things a little bit neater and more consistent across the board. Have you, I don't think I've seen you stream in a while, Coffee. Are you not streaming? Thanks for the good luck. I appreciate that. You took a break? Yeah. That makes sense. Well deserved. Well, let me know when you're going to stream again, and I'll definitely tune in if I can, for sure. Do the backends have like specific defines in C and C++, so you can tell if you're using X11 or Wayland? Yeah. So the way that I've done it, at least for all the other platforms, is if we actually go to platform Linux, since that's what we're on. If we go all the way to the top, I actually have these flags that I set in defines where I do some platform detection. And so right now it's just generic for Linux, right? Just because I have one Linux layer. Eventually, since this is X11, I'm going to separate out this into like a X11 Linux and then a Wayland Linux. And there's going to be some overlap between those two, so there'll probably just be a Linux version of that as well for any of the overlap. But that's more or less what we're doing for that. Windows is the same thing. It's basically all guarded by ifdefs, more or less. Let's see. You'll have to poke around because you're not able to get compile flags text to work. Yeah, so compile flags text basically just has to be alongside of your source, right? So in my case, each of my... Let me think. Is that at the source level? No, it's at the... yeah, it is in the source folder. So all of my source, which actually I just noticed... Right. Okay. So all of my source lives in this directory, right? And so that is where my compile flags should live. I believe that's the way I've got it set up. Where is it next to it? No, it's next to it. So, like I said, most of mine aren't generating because I've blown a lot of them away because I've moved a bunch of stuff around. But essentially, it should just be one line per include. Like here's probably a better example of how to get the other includes to work, right? If you're including like Vulkan or something like that, you would just include the include path in this list, right? So one item per line, essentially. That's more or less how it should work. All right. Hope that helps. Okay. So... let's see. I think that's most of what I've been doing offline, right? It's just kind of moving moving a bunch of stuff to the actual, moving a lot of stuff to the window and to be associated with the window. So if we look at the Vulkan backend, now whenever we create the window, we set up that that sort of backend state. We set some defaults. We go ahead and we create our surface, right? And we associate that with the window. And we create our swap chain, and that's also associated with the window. And then this out window render target count, that doesn't actually exist, so we need to fix that. Because basically what I did was I just took this chunk out of my initialization code and plopped it in here, and now we're just sort of refactoring it to make it work. Okay, so we have render target count. Do we have, I guess this is going to be render target count is really, so the other thing that, the other thing I wanted to get rid of is there are a lot of portions of the engine that are aware of the fact that we might have more than one render target, right? So, for example, like the material system was aware of the fact that we triple buffer, right? And so what I'm going to do is I'm actually going to take that information away from the entire rest of the engine, because the engine shouldn't know or care about any of that stuff. It should just say, hey, here's my current material info, set it. And then the renderer should go, oh, okay, well, you know, which set of descriptors sets should we use for this, for which frame, and for what window, right? And so that is another thing that we need to fix, because that's kind of been a long-standing issue as well. So that's another thing that I've been kind of like trying to clobber whenever I see it, right? So this out window render target count, it's not really something that should exist outside of the window. And in fact, let's see, we have context. That's not the context anymore. It should be renderer window swap chain, right? Because that owns the swap chain now. But I don't think we need to set that count individually. We could just use the swap chain count, right? So let's actually just do that. Let's get rid of that. This swap chain create. Let's see. I think swap chain creates. It is a void return. That's interesting. So the question there is, since it is, let's see, we have create. Can this fail? I'm pretty sure it can. Yeah, it can. Why are we not tracking that? I mean, technically we're asserting with this VK check, right? But we should probably actually be... Okay. I'm going to put a to-do on that. Well, I mean, I guess technically our asserts cover us, right? But maybe we want to log that information. I don't know. Should this return a bool? Just put a note in there, put a pin in it for now. We'll move on. Okay, so this actually does return a Boolean. So if we get to this point, we are successful in creating the internal window state. So that should be fine. I guess we should also spit out the window name here since we're doing it in the error cases, right? For window, all right, and then window name. All right. So the other half of this is obviously when we destroy the window, we need to destroy the swap chain, which is done here. And then we need to destroy the Vulkan surface, which is done here. So all of that should be good. The only thing that we're not doing is we're not actually freeing the memory that we allocated here. So let's do that. So we're going to do k-free. We're going to call it against the backend states. Size of render, backend state, memory tag render. Right? Don't want to leak that. Window. Backend state equals 0. All right. Okay, so we should be good in terms of that. We'll see what else we've broken down the road. I think our resize is already actually good. I think we did that last night, so we actually should be good in good shape on that. There is some work over on the engine side that we're going to have to do, because some of these things have actually changed in terms of what we pass it. So in engine run, there are a few places in here where we're calling out to the renderer and we're not passing window information. So our sort of main loop here always just kind of assumed that we had one single window, right? And we didn't actually even pass the window around or any of that stuff. And so what we really should be doing is passing the window like in our renderer on window resized. And I believe that now takes the window as its first, as the first argument. So what we're going to do is I'm not going to support multiple windows at this level yet, right? We're just going to say, let's take our array of windows, just pull the first one out of it and just use that, right? Just so that we can kind of get back to a point of working. And then when we actually go to build in our full multi-window support, we'll have to build out a little bit more logic into this engine run, right? This is our sort of main, our main loop, if you will. So this is going to want the address of engine state windows, and we're going to take sub-0 of that, right? Now, the engine width and the engine state height no longer exist. I've removed those because they're not specific enough, right? We don't have a global width, we don't have a global height. We only have a window width and a window height. And so we actually need to pass that along as well. But I think we have this in a few places. So we're actually going to need to update this. Okay, so we have engine on resized. And here's where we actually check that. I don't believe, though, this does not take into account a window. All right, so do we have this anywhere else? I don't think we do. Just here. So our engine on resized. Our engine on resized technically should go away, right? Because we actually have something from the platform that feeds us the window information. So what I'm going to do is I'm actually going to take, I think I'm going to get rid of this event in its entirety. I'm going to take all of the code from engine on resized. I'm going to do basically all of this logic. Right? And I'm going to go to engine on window resized. And oh, I see. We were firing off another message that says event code resized, right? Which is not necessarily what we want to be doing or should be doing. So let's go ahead and replace that with all of this logic, right? And I'm actually gonna, let's see, event code resized. How many places are actually listening to this? So we have the macOS layer that's firing that event because we haven't refactored that yet. So those are all going to go away. The debug console listens to it. Okay. So that may have to change. The engine fires it and listens to it. So those are going to go away. Okay, so that's actually not a huge deal. So I'm going to get rid of this. We're not going to fire that event anymore. We're going to get rid of it. And so in our window on resize, we're going to mark the window itself, and I think that might be, is that going to be under renderer state? Resizing. I don't think we actually have that stored anywhere. I don't believe we have that stored anywhere. So let's go over to, let's see, platform.h. Taman, how's it going? Good to see you. Smudge, good to see you too. How's it going? Good to see you guys. So we need to store the resizing flag. And we actually need to store like a cached width and height on the window. So let's do a U16 width and a U16 height, and then a Boolean to say resizing, right? And over here, we'll do window resizing is true. Oh. That's const. Why did we do that as const? I guess because the window resize would have already happened. So let's think about this for a second. So if we... So theoretically, the platform layer should apply this first, right? And we're just telling the engine, hey, this window has already been resized. Okay. And then we're saying here if this actually changed, which we should probably also check in the platform layer instead. And then here we can actually check for minimization and suspension, which are also going to be things that we have to take into account. All right, so actually really the only thing that we care about, what we should probably do, now that I think about it, when we do resize, right, here's where we actually do the resize callback, right? Configure event. So this is probably where we should actually do these checks. All right, so we have a resize event coming in from XCB. In this case, we should probably do like this check over here, this guy. So let's do that. Let's do let's create a block for this, right? So we'll do if, and let's actually split this out into configure event. Like let's pull this information. So we'll say u16 width equals ads, because we have ads. So for those of you who are new or can still hear me talking, on the Twitch side, we're given ads once every 30 minutes for up to 90 seconds. So I just like to pause the stream so that nobody misses anything. So that is what we're doing right now. And so if you need any sort of bio break or anything like that, now's the time to do it. Seth G, yes, it is the Heartbound soundtrack. Yes, if you do exclamation point music, that is what that is. That's what's playing right now. Is my bot going to respond to that? It should. There it goes. Okay. All right, so we got about 40 seconds left on ads, and then we can continue. No worries, Smudge. I gotcha. RCW, good to see you. How's it going? Almost done with ads. Yeah, Heartbound is a great game, and he does allow anybody to use the music. Yeah, I think I was one of the first people to actually ask him if I could use it. Even though he had it sort of written on there, I still reached out to him and asked him anyways, and he was very cool about it. Okay. Doing well, decided to hop on the Refactor Tractor too. Nice. Fixing some logger issues. Yeah, we have some of those to fix too. So what I'm going to do is extract width. So we'll do configure event. And that's going to be width. And u16 height equals configure events height. And here we'll do if width is not equal to window width, or height is not equal to window height. Then we're going to trigger a resize event. That comment was useless. So this should go in here. We should only trigger the callback if there was an actual change, right? Okay, so that was one thing. I suppose the other thing that we should do is, let's see. I guess we could do w.resizing. Oops, resizing, if I can spell it right, equals true. So we'll flip the resizing flag on there. So that will call out to this function here, because that's essentially the callback that gets set. Now we have frames since resize equals 0. So I think we'll be okay to continuously check this frame since resize. That should not be engine state either, actually. So that should be we should have another thing in here. Let's see. Frame since resize. I think we set it to like 30 in the engine, right? But we need a counter on the actual window itself instead of the engine. A U8 probably would be enough to count in most circumstances, but I'm actually going to do a U16 just to be safe. So we'll say frames since resize, right? And I guess what we can do is we can say if not W resizing, we can take this into account here. Flip the flag to true, and then also say W frame since resize equals 0, right? And in fact, that should probably always be set, actually, now that I think about it. So instead of, yeah, we'll just always set it. That's fine. Okay, so we'll always make sure that the resizing flag is true and that the frames since resize is also true. Now, we're going to also have to update the width and height on here. So we're going to do width equals width and height equals height, right? So that eliminates most of this stuff being done from the engine. It should be done in the platform layer, which makes more sense. And then let's see. So we have minimized, which is technically where the width and height equals 0. And that suspends the engine, right? It keeps it from actually trying to render to a render target of 0 by 0, because that's an error, right? I think we might want to move, instead of having like an is suspended flag, we might want to just say check the width and height to see if it's actually like a real size. Although suspended would be easier to set. We'd have to have a suspended, the suspended is really going to be per window, not per the engine. We're probably going to need to rethink the suspension logic, actually. So I think for now, we're going to get rid of that. Actually, you know what? I'm going to copy the comments over here because those are somewhat useful. Update dimensions. Okay. All right, so that I think is all we need to do there. So we can get rid of this and this. Don't need that. And actually, the only thing that we need to keep out of this is here. Right? So we can get rid of that. And in fact, since width and height are stored on the window itself, technically speaking, we don't actually need to even pass that here, right? We can actually just say, hey, this window was resized, and just look at its width and height. I don't think we need the old width and height for any reason. So engine on resized. Let's take a look at this function pointer. So the platform window resized callback. We're not going to pass the width and height anymore. That's contained in the window. Let's simplify that some. So engine on resized is going to go bye-bye. So let's get rid of that. Engine on window resized we do need to keep. That shouldn't be return true, it should just be return. Actually, we don't even need that. Okay. So let's see. Frames since resize, that should not be part of this anymore. Should be per window, we're doing that. This should also be per window, we're doing that. So we can get rid of that. This is the old engine unresized. We can get rid of that. We can get rid of these guys. Incompatible function pointer. Yeah, that's because we need to get rid of width and height. And we need that one more place here. Right? And then this is going to be window width and window height. Right? We also need to have a fix me on here. This should be per window, not global. Okay. So we have that. Oh, this is no longer a to-do. Okay. So the second part of this, right? Since the backend or the platform rather is instantly handling this bit. Oops, the callback no longer needs these. Right. Since the platform layer is immediately performing the width and height change, right? And we only actually call the callback if that has changed. It's up to the engine then to say, hey, when do we actually want to reach out to the renderer to say we are done resizing? And so that is what this this block of logic has done right here. So what we really probably ought to do is I'm going to grab a convenience pointer. And I'm going to just say k window w equals the address of engine state windows sub-0 with a fix me need a better way to select the active window. Right? So here, Osic1, thank you for the follow. Appreciate that. Welcome. Let's see. Hello, will you be taking part in the game jam this weekend using your engine? My engine's not ready for it, frankly. So no. I do eventually want to do that, but this just isn't ready for it. There's no way. It's not ready for prime time yet, unfortunately. I do want to do one of those eventually, though. It's just, yeah, we're not there yet, unfortunately. Singy, hello. How's it going? Roman General, good to see you. Happy coding. Yep, same to you. You got an early morning and need to sleep. I totally get that. So can you explain the swap chain and depth buffers again in great detail? You're a funny guy. You're a funny guy from Lake. All right. Actually, ironically, we did just kind of go through some swap chain stuff not too long ago, moving it to be associated with a window. All right, so we have selected the window. And so everything we're going to do here is basically going to be against that window. So we're going to do, instead of engine state, it's going to be window. Here as well. And here as well. And we should probably also configurable delay here instead of magic 30 frames. Right, we should probably make that configurable. Not going to bother right now, but I'm going to note it. So instead of this, we're just going to do W. And to that, we're also going to say W and W. I suppose the renderer on window resized doesn't really need to hand off the width and height separately anymore either, since we're handing off the window. Technically speaking, we don't need that, right? And actually, this can be const, because nothing here should be modifying that, right? So, const pointer to the window that was resized. This should be handles window resize events. Clear the highlight because that's getting kind of annoying. All right. Front end C. Let's get rid of the width and height out of here too. All right. And this should be const, because we're just reporting it, right? Oh, right. We don't need this crap anymore. This is what I was talking about we can actually get rid of. So, what we can do, because we don't have this window states anymore, that's actually integrated directly into the window itself. So, the window, this is K window renderer state. Window state is going to be window render state, right? And so we don't need this. We don't need this. All right. So we actually don't need this if check either. So now we can just say window state frame buffer width. So this is another one of those things that we probably don't need an extra copy of, right? Like frame buffer width and height is going to be the window width and height. So we probably do not actually need these, I'm thinking. So let's get rid of those. And we can do window resized. And that is also something that we can change, right? So we have the backend interface pointer and the window. We do not need the width and height here, right? So we can get rid of that. And just do window. Actually, what did that want? Did that want the backend window state? Oh, the renderer window. Okay, that makes sense. Yeah, we should probably pass it window though, actually. We should probably pass it the whole thing and just dig out what we need, because passing const. Oh, that should be const as well. All right, there we go. Window resize, does that return anything? No, it does not. Okay. Maybe I'll remove this check if window in engine is created after renderer is stood up. Yes, I don't think we actually I don't think we actually need to do that anymore. That's a good point. I think we can actually simplify that even, oops, I've deleted the state pointer. I need that. I just don't need this stuff. So let's simplify that even more. Do we even use the window state? I don't even think. No. So that's a lot cleaner, right? And now we can just sort of just, it's nothing more than just a pass through to the back end, actually, is all it is. Which actually, we could probably save ourselves to that engine systems get. We could save ourselves a call to that if we just force a pass through of the renderer state as well. So struct renderer state, renderer system state. Right, if we do that, then we can get rid of this. And this becomes state backend and state backend, right? And then this can also kind of just do the same thing. So struct renderer system state. So let's see. So our parameters is state block of memory. Need that. Right? So it's just the state and the window now. And since the only thing that's going to be calling that is going to be the engine will have the state that it needs, right? So we can say engine state systems renderer system, right? And then we can get rid of the width and height on there, and we should be good to go. What did I, oh, comma. There we go. Okay. And that's return type void, so we don't need to do anything with that. Renderer frame prepare. Okay, so some of these function names changed, and the life cycle of some of this stuff changed. So if we go to up here, I kind of made some notes on how this is going to work. So what we do is we actually have a our frame prepare actually does something completely different now. Essentially what it does is it increments the renderer frame number on the front end, and that's all it does. And then the next call that we would make would be prepare window surface passing through a window, right? So that would verify the swap chain, get the image index, all of that stuff that we were doing in frame prepare before. Now we're going to do that in frame prepare window surface, right? And then we have frame commands begin and end. I think I typed end in here twice. This should be begin, right? And this was basically what was just called begin and end before. So what this is really doing is starting our command list / buffer. And so we're going to just rename it to that effect, right? And then in between that is where we do all of our render pass stuff, our draws, all that other stuff. And then we do frame commands end. And then we do frame submit, which submits the command list buffer for execution. And then present, which takes in a window telling us what we should present, right? And so some of these functions over on the renderer side have been renamed to reflect that new way of doing things. So we do have the renderer frame prepare, right, which is here. So that's the old version, right? So we don't want this to move. So what we actually need to do is right after metrics update, we need to say renderer frame prepare. And that's going to be engine state systems renderer system. and we're going to pass in pframe data. Right, and actually, no, that's going to be the address of engine state pframe data. There we go. Okay, and I think it does return a Boolean because we might have a backend that needs to fail this. So if that fails, we're just going to continue, right? And we'll try again on the next loop. So this render frame prepare is actually now going to be render a frame prepare window surface, which takes in the system state window and, well, let me move this up so you guys can see it. It takes the system state, the window, and frame data, right? And so that is going to be prepare window surface, right? And we're going to pass through, again, the render system state, so engine state, systems, render system, and then the window itself, which is just W, and then pframe data, right? And in this case, we say don't bother checking the result of this since this will likely recreate the swap chain and boot the next frame anyways, which is true. So we can actually rely on that. We then call the game instance on resize. So that is another thing we have not actually updated yet, right? Because we actually need to say, hey game, your onsize, your resize actually needs to take into account a window. So I guess that's going to be the next thing that we have to do. Let's see. Will be really cool when you could actually make games. Good luck. Yeah, it will be really cool. I mean, technically speaking, we could make something now, but it'd be a little bit tough, right? And that's why I'm going through this refactoring now and trying to clean stuff up, is to get us a little bit closer to that goal. Watch the swap chain video again today. I understand the reference. Awesome, Taman. That's good. Trash Can, how's it going? Good to see you. Hello. Okay. So, I guess we can take a look at this real quick. So this is an application types. It takes the application instance, and then instead of width and height, just like before, we're going to take a struct k window, and what we're going to have instead. Right, what we're going to have instead is a pointer, actually, that should be a const pointer, right? Because we shouldn't be changing that. A constant pointer to the window that was resized, right? And instead of on resize, we're going to call this on window resize, right? And so here we can say window resize, and we're going to pass W there, right? So that's that. And then once we reach this, right, and we've passed the number of frames that are required since the last resize, we're going to say that the resize is finished at this point. So instead of marking that on the engine state, we're going to mark that on the window. So we're going to say the window frame since last resize is 0, and window resizing is false. Right? And that's going to kind of kick us out of that resizing mode. Okay, so that is done. The next thing we're going to have here is another call to prepare window surface, right? And so this is going to take the engine states, systems, render system, and then it's going to take W and the pframe data, right? So there's that. Again, this can also happen not just from a resize above, but if a renderer flag such as vsync has changed, it may also require resource recreation. To handle this, notify the application of a resize event, which it can then pass on to its render graphs as needed. So we might actually handle that a little bit differently too, along with ads, because the Bezos has to get paid for the ads. So we've got about a little over a minute left on ads. So we'll just take a break so that nobody misses any content. Hope you guys over on the YouTube side are doing well tonight. It's a little quiet over there on that side. Always feel free to jump in. We've got about 40 seconds left on ads, and then we can continue. More ads, new yacht. Exactly. Yeah. You're not wrong. Not a new yacht for me, though. All right. Ads are dead. So for those of you who can't hear me talking during the ad break, we like to just pause the stream whenever ads come up. And we're served those once every 30 minutes on Twitch for 90 seconds. So I'd just like to pause the stream across the board so that nobody misses anything. Okay, so this next bit is essentially going to be a duplicate of above, right? So we need on window resize. And instead of engine state width and height, we're just going to pass W. So there's that. All right, so this is where we actually begin our commands, right? And so I've been thinking a little bit about this offline, and it's not something I'm going to do right now, but I am actually considering exposing like a command list type of structure to the renderer front end, just so that it could make it a little bit more obvious in terms of how everything's working in terms of the actual flow of a frame. And that may actually wind up simplifying our API a little bit as well. I don't know. I'm not going to do it in this refactor, but it might be coming in a future refactor. But for right now, this is going to be command list begin, right? And I forget, I think that does take a window, which I don't know that it actually needs to, but it does take also engine states, systems, renderer system, and then it's going to take W, right? We can always refactor that back out if we don't need the window for that, but we'll kind of see where we wind up on that.
Stream recently. Hope it is all going well.
Diamond, good to see you, and thank you for the resub, the tier 1 resub. It's good to see you. I hope you're doing well. Yeah, and it has been a minute since I've seen you, so yeah, welcome. Thank you very much for the support. I really appreciate that. Okay, so... Oh, your family's in town? Well, that's good. Definitely spend time with them, for sure. That's super important, right? The VODs for this will be around. So, yeah, definitely spend time doing that. I do appreciate you hopping on, though, and saying hi. All right, so we'll change this to renderer frame command list end. That's going to take engine states, systems, renderer. and W. Let's see. Exposing the command list would simplify stuff when multi-threading the renderer. That's potentially true, yes. I'm thinking it's going to simplify things in a few other ways too, because like the thing that we have about this, right, is the other step that we kind of split out. Is we also have this frame submit, right? So that's in Vulkan's case, that's where we take that command list that we've built up and we submit it to the queue for execution, right? And then we have a present, right? So this frame submit is actually a new step that's been exposed now. And so right now, what queue that gets that actually gets submitted to is completely out of the renderer front end's control. And maybe it should be, but I'm thinking that might not also always be the case, right? So I'm thinking the more I think about it, we might need to expose some of that stuff. The only thing is when I go to expose that, it's got to be done in a render agnostic way, right? So I can't expose like Vulkan commands themselves. I have to expose something that's kind of close to that encapsulates like maybe one or two of those commands. So it's not a small amount of work, but we'll see. We'll see, right? See where we land on that. I don't think... Oh, this does return a B8, which I think also means... Oh, weird. So we were checking this one. But we did not check the results of ending it. Okay. Which I suppose... I guess it doesn't matter as much. But... Actually, I'm just gonna do this. And shutting down, running is false, break. Right. Okay. Okay, so we end the frame. So we're going to say add the recording to the command list, right? And we'll say up here, start recording to the command list. Right, and then here, before we present, we actually have to submit this work. So we need to do renderer. Let's see, what did I call that? Frame submit? I think. Did I might not have actually created that function yet. Come to think about it. Frame present. I did not create the function yet. Okay, so that's another thing we're gonna have to hook up. So we'll do. I guess, yeah, I'll just return a boolean. I don't think we really need a boolean here, but everything else has one, so. Renderer frame submit, right? And this is going to be struct renderer system states. Oops, states. And I guess technically, since the command list is also taking window, I'm not convinced that we actually need the window context for all of this stuff. We don't need p-frame data either. But we might need that, right? So we've got that. So let's go here. Oh, that's funny. I implemented it here. Wait a minute, did I actually remove? I did remove the window from some of this stuff, just not in the header file. I don't think this needs frame data either. I'm gonna get rid of that. Heck with it. I already changed that, didn't I? I'll leave it. It's not gonna hurt anything. Okay. So I guess I forgot that I had actually removed these because I was like, I don't think I need those, right? So we'll do frame data, p-frame data. Okay, so let's get rid of the window info here. Okay. All right, it makes sense to have the window for this one. It makes sense to have the window for present. I don't think anything in between that really needs it, though. Which is immediately going to break a couple of these things that we did here, but not a big deal. We just need to remove the W parameter. All right, so we have that. All right, and then this is going to be render frame submit. And so we want engine state systems renderer system, and then oops, we need the address of engine state p-frame data, and whoops. If that fails, failed to submit work to the renderer for frame rendering, I guess. Should I just, I guess I could break. And do this too, I guess. Should probably clean that up and figure out a better escape scenario for that. And then we have renderer, I think it was renderer frame present, isn't that what it's called? And this one does also take the engine state render system. That does take the window, right? So that should be most of what we need there. I don't think we have to touch any of the rest of this stuff. So let me actually build this real fast. So far we get into the renderer. Okay, that doesn't surprise me. That's kind of where we were before. Let's see. Another thing you can do is expose a command for render commands that internally can be recorded before being translated and submitted as actual graphics API commands. Reordering could be necessary to either correctly insert resource transition barriers. Yeah, so I've thought about doing some of that kind of stuff too. Ruche, thank you for the Yar hype. I've thought about doing some of that kind of stuff too, and like actually eliminating some of the calls like command list end and command list begin, right? Like we might not actually need these explicit calls. We might just be able to kind of put those in place after we build out the command list, right? So we could just like say build command list and then execute command list. And under the hood, the command list says, okay, begin recording, add all these things, end recording, submit the work, blah, 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 blah. So that might be another way of doing it. Fits the render graph construct really? Yeah, I think it does. And it'll probably simplify our render graph quite a bit too. But again, that's probably going to be, that might be a post 1.0 thing, to be completely honest. We'll see. Because that's not going to be a small change either. Okay, so the renderer front end, I think, is what was bleating. Yeah. Yep. Okay. All right. So there are a couple things here. Let's see. Prepare Windows Surface. Backend prepare Windows Surface. What does this want? The renderer window state. Okay, we don't actually want... We don't want to do that. We actually want to pass through just the window, I think. That way, at any point, if we need any of the other information from the other levels of detail, we have that, right? So let's actually convert these both to do just that. Right? I know the backend is probably only going to need backend data, but we're not guaranteed that that's going to be the case. We might need something from the top level structure, for example. Okay. I don't know if that first thing was a warning or not. So let's see. Let's go all the way to the top here. So we've got a bunch of deprecated warnings. That's good, because we added those things in there. We've deprecated this geometry API. All right. Frame buffer width. Line 98. Okay. So we'll take a look at 98. Render system initialize. Okay, so this is default frame buffer size. Overridden when window is created. So we don't need this at all anymore. That is actually done when the window itself is created. Initialize the back end. So, what is this bleating about here? No member named windowed render target count in state. Okay, right. So this is one of the things that I was talking about where we shouldn't really be concerned about like render target count, right? If we're double buffering or we're triple buffering, or I don't know, we have friggin' 5 swap chain images as the Mesa drivers on Linux do. Front end should not care about that. The rest of the engine should not care about that. And so I am actually going to do things to completely get rid of that requirement for anything else in the rest of the engine and leave that up to the renderer backend to handle all of it. Which should also simplify code in a lot of places, at least outside the renderer. It might make our renderer backend code a little bit more complex, but I'm okay with that. So I think the first place to do this is going to be the backend initialize here. So we have the backend, the config for that, and then the out window render target count, right? So this whole thing we don't need, which means that that parameter goes away, right? And so goodbye. Okay. So we've got that. And I think what we'll do is we'll probably just we'll remove all this stuff out of like the renderer front end, and we'll remove all this stuff out of our engine code if there's any in there. I think the only thing in there was really the material system, and I was already able to remove that. The only other thing I can think of are our render graphs are going to need some of that stuff removed, but we'll handle that when we come to it. Okay. Let's build this again and take a look at... All right, so we're down 1 error. That's good. So let's see what the next thing is here. Window states, frame buffer width. Okay. All right. So let's do a search for frame buffer width and height, right? So window renderer state, frame buffer width and height. So this is really just the width of the window itself, which actually, here's another spot where we're saying, hey, this window's been created. Here's the width and height, but we don't need to do that because we actually have this to tell us that. So let's go here and remove these as well, because we don't need those. And remove these as well. Let's see. So we do need the render state to be created. We don't need those, which are just a copy of that. We'll have to address that fix me later. And then the back end window create does look like it still takes the width and height, so we got to fix that too. So we just want it to take the window pointer, right? So we don't need that at all because the window tells us that now. Okay, so we've got that. Do we have frame buffer width? No. Okay, we don't. All right, so on window destroyed. Okay, this was another one of those weird lookup situations that we've since resolved. So let's see, on window destroyed. Do we need I feel like our platform layer is going to tell us that the window has been destroyed or created. So we should probably also do something to avoid this lookup here, right? So that's also kind of another common theme that we're trying to do here. Front end. Oops. Window created. Here we go. So we should also be taking this. And we should be taking that here as well. Right? And so over here, we can add that, and then we can add that. Right? And then we can get rid of this, and instead of saying state pointer, we can just say state. Right? And same thing for down here. State. Let's see. So, we don't need this. We don't need any of that. Do we need, I don't even think we need the window state, frankly. We don't need that. We don't need that. Or any of that. Frankly, the only thing we need is just a call to the renderer backend. So it should be state backend, window destroyed. I think that's just destroy now. And then window. What is this bleating about? Window, okay, so it's passing the wrong type. Okay, so the interface for this guy is should be just taking a regular window. And yeah, they're actually both doing that. So these should both be taking just the K window structure. All right. Let's see. Hey, seen a lot about deferred versus forward lately. What will your engine use? So right now we're using forward. Oh, Ava Sarah, first time chat, welcome, but also bye. Good to see you. Thank you for the stretch redeem, by the way. I will take that. You've seen a lot about deferred versus forward plus, right? Or forward versus forward plus. So right now we're using a forward renderer because it's the simplest thing to set up. We are also going to set up a deferred renderer pipeline, which is basically just going to be a different render graph setup, right? And then we're also going to set up a forward plus rendering pipeline. So we have support for all three versions of doing things. So that way, depending on whatever the game's requirement is, you can use those different pipelines to achieve those things. And so we are going to be using all three of those. We don't have compute support yet. So Forward Plus does require compute support, so we're going to have to add that first. But Forward Plus is also going to be the last one that I add, right? So I don't think we're going to get to adding a deferred renderer before we release our first game. But probably right after that is when we're going to add it. So the answer to that is eventually all three. All right. This should just be window. Okay. Window destroy, I think, also is just a void. Yes. Okay. So those are good. Let's build. Only one error. Hey, that's not too bad. Oh, it's in engine.c. Okay. That's not too surprising. Okay, so when we create our window, oops, we were notifying it about the width and height, which isn't necessary because we already have the new window. We also need to pass on the engine states systems renderer. Cool. All right, back to the renderer front end. Okay, so we've identified a lot of issues there. We're down to 10. All right, so let's have a look here. We have renderer window attachment get. Okay, so these two actually are an issue. Actually, all four of these are an issue, right? Because these are taking into account attachment indexes, which are having to do with like triple buffering and stuff. So these two shouldn't even exist. So I'm going to kill them. Actually, you know what? Before I do that, though, window attachment index get. Yeah, we're gonna leave all this stuff in the back end, right? So I'm going to peak definition on this, and I'm going to say. So for the attachment index and the attachment, the get. Let's wait a minute. Attachment count get. Yeah, we don't need either of those anymore. Depth attachment gets. We are not going to take in the index for that anymore. Just going to take in the window. Which actually, technically speaking, we probably ought to rethink about how and where our depth attachment is actually stored as well. For now, the window associated with the depth attachment. And I know that that doesn't make sense. We are going to refactor that. But in the interim, that's essentially what the depth attachment belongs to. That and adds. Add time already. Jeez, time's flying tonight. Let's see. Roth, happy Mr. Tree. Nice. So we just got about a minute left on ads. I'm going to go ahead and hydrate. I might rework my ad screen again, just to make it a little bit more explicit. And to yell at you guys to go hydrate, because there's that. Yeah, Tammin, there is also Deferred Plus, you're right. Yep. Let's see, what is the first game going to be? Oh, you know what, I should probably answer that after ads. Okay, ads are done. All right, so the question was, what is the first game going to be? So the first game is going to be really simple. It's going to be a arcade style game, right? And it's just to essentially run the engine through its paces to make sure that it's fit for building a game with, at least a simple one, and actually releasing a game on it. So the idea is, we're going to build a super simple game for the first game of the engine, and we're going to take that all the way to release. We're going to release it on Steam and everything. And so the idea there is that we want to use that to batten down the hatches and really make sure that this thing is solid and test the crap out of it and stuff like that, and really get the runtime as solid as we can with the features that we have so far before we go adding anything else, right? So it's going to be a very simple arcade style game. It's going to be the first game. The purpose of that is not to make some crazy complicated game, but to make sure that it works with something simple first. And then after that, we'll build something that's a little bit more complicated, and then we're going to move on to a large game that's going to be a much, much larger product, right? So that's kind of the plan. After a month, I finally finished the math library. Nice. Yeah, mine probably took about that long to write too, more or less. It's a lot of work. And I haven't even done SimD yet, which is another thing. Space Invaders. Yeah, I mean, it's probably not going to be any more complicated than that. I'll say that. It's not even going to use physics, right? For example. Okay. So, we have window attachment get, which this API is probably going to change too, but that no longer is going to take an index. So we can delete that. All right. So window attachment index get. Yeah. Okay. So these two can go. Which means over on this side, what were those called again? I nuked them too soon. Attachment index get and attachment. Yeah. So we don't want these at all anymore, right? So we don't want those. And then window attachment get, we don't want an index for that anymore, right? We just want to get the attachment, right? And if there's an index that needs to be done, it needs to be internal, right? This is going to be window and You know what? It's actually going to be const pointer to the window. A constant pointer to the window whose attachment to get. And this is going to be the render target, period. Not at the given index, none of that stuff. So we've got that. To do a tower defense. Should I go against Cakes on his tower defense game? Although he's doing a 2D one. Our first game's going to be 3D. You did manage to do SimD for most of the important stuff. Nice. Reading GLM was very helpful. Yeah, I probably will be referencing that as well. Because SimD is like one of those things that like, I've done it, but it's like you do it and you forget about it, you know? It's like once you've done it, you know, why do you need to redo it? Except in this case, like where we haven't actually done it on camera, that's where we're going to be doing it. But ordinarily you write that stuff once and forget about it. Unless you have a bug or something stupid. All right. So that's that. So that should be good. And then over here on the left side, this is actually going to just take const struct k window, right? And this is going to be const struct k window. And when we go to the back end, all the back end is going to ask for is a window. Does not right now. We're going to change that though. So this guy, oh, it is there. Struct window. Yeah, this should be const though. No need for it not to be. There we go. Okay. Window attachment get. What all calls this, I wonder? So I think it's mostly used, I want to say, by a render graph. Render window attachment get. Yep. It is, well, okay, that's the Vulkan plugin. That's the front end. So it's just called in a couple places by the render graph. And that's it, actually. It's just called by the render graph. Okay, so that's actually not going to be too bad to refactor at all. All right, we'll just, we'll refactor the... So this bit, where we're talking about all attachments for all frames, we're going to refactor this logic to abstract that stuff away. To say we don't need to do that within the render graph, right? As far as the render graph is concerned, we have one attachment, and that's it. All right, so I'm not going to worry about that for right now. We'll come to that bridge later. All right, 2 things left in this file. That's good. So 1061. Active viewport. Here we go. Okay, so our active viewport is really only just held in here. So I guess the real question is the active viewport get and set, like what actually all calls that? So viewport. So this looks like it's used by our render passes. That's just the front end. That's the back end. Yeah, looks like our render passes are what actually calls that. So why did this wind up being an issue? Were we saying that the active viewport needed to be associated with a window? So we have the viewport and the scissor. I guess theoretically, it doesn't have to be associated with a window, right? Because if we want that window association, we could just use the window width and height to set this viewport, right? This probably doesn't have to change. Okay, so let's do instead of this, oops, let's actually take these, right, and go to I think we just did window created. I think in window, or renderer rather, initialize. I think here. I guess here's where we can put that, right? Right, and then this is no longer an issue. Okay, so I think that is fine. Okay, so now our render graph is the next thing we're going to have to tackle. Okay, and that's not surprising because that's our window attachment get stuff that we were just talking about. So we have a few places here that this is actually used. So let me see. Render graph finalize. This is after we hook up all of our sources and sinks. We're looking at our global sources. For each global source, if that render graph source is origin global, meaning it's not owned by anything, then we're saying our source textures we're creating one for each attachment. So we get the count of those rather. And then we're doing this. So I'm thinking actually, where we have the source textures, where are we doing anything else with these textures in here? I'm thinking this source textures array just needs to go away. And what we can do is at the time that we go to actually use the source texture, at that point we can actually do this query instead of trying to store it ahead of time. That makes sense to me on the surface anyway. So we just have an array of texture pointers anyway. So let's do away with this. Right, and we actually don't need to do any of this, but I'm not going to nuke it just yet. I'm going to comment it out. We generate render targets. Retrieve texture pointers for all attachments and frames. So this is kind of the same thing again, where we have attachment texture, target attachment counts, so for each attachment, and then we have pass render target count. That also needs to go away. So let's actually pass targets, render target targets. Okay. So an array of render targets used by this render pass. This should just be one target. And then we don't need the count. Right? So that means that we can go here. Oh, there's a lot of logic in here. Let's see. Render target create. Yeah, see, we had some ugly hacks in here where we were using like the first texture width and stuff like that too, which is gross. So yeah, that's all gonna have to be, this should all be deferred to the back end. So when we create a render target, like, we shouldn't have to pass this. We shouldn't have to pass an attachments array. The pass is debatable as to whether we should have to even pass that. And then we have a width and a height. But we definitely should not be doing multiples of these. Well, actually, I guess attachment count makes sense, right? But we shouldn't have to be creating more than one render target. Right, so this should just be target. So we don't need this for loop. Target is going to be the address of render target. Pass target. Why does that still say targets? Render pass. Yeah, targets was definitely changed there. Okay. There we go. Okay, I guess it just didn't update yet. So that is essentially what we should be getting, right? And then, you know, we have our engine state, systems, render state. Oh, does it not even need that? No, it doesn't even need that. Wait a minute, I thought we did add that. Did we not? Well, no, we didn't. Okay. Oh, but we should. We definitely should. Yeah, we should definitely take in... We should definitely refactor that to take in the state pointer. That way we don't have to retrieve it like this every single time as well. Okay. Let's see. What is my font? Let me think. What is it? It's Meslo LGS, I believe. Let me see. This is my WES term config, which is where my font is defined. And I think, yeah. So I'm using the Meslo LGS nerd font. So that's the font. As far as the theme, my terminal is using the GitHub Dark theme, but then my Vim is actually using Adawada. So if you're wondering what my theme isn't for, or like what my settings are for NeoVim, I actually have an article that I wrote up on my website that has all that stuff. So I'll drop that link on both sides. So I hope that helps. Dink Searle, first time chat, welcome. Good to see you here. All right. So I'm just trying to think in my head now how we want to simplify this a little bit. So first off, I'm going to eliminate this call to get the engine state, right? So we want renderer system state, right? We want that, remove that, and right. So we'll do that, and I'm also going to do that same thing here. All right, and I guess in the header as well. All right, so there and here. Do I need... Need that. Get rid of this. And that. And then over here, I can essentially do this call once and store it in the render graph. All right, so I guess, or I guess I could just do it here. It's fine. All right, so I'll just call it renderer. Renderer system states. Include engine, and then renderer. And this also wants the window, doesn't it? Does. So that complicates things a little bit. Because theoretically speaking, now that I'm kind of trying to think this through, a render pass is not tied to a window. A render graph is not tied to a window. Which I suppose is actually even more of a reason not to do this forward lookup, right? We should probably be resolving that like at the time that we're going to go render do the thing. So I would actually even argue that we probably shouldn't even be handling this render target regeneration here at all. We should only do this if the render graph itself owns those render targets. And if those render targets are owned by a window, they're automatically going to be recreated anyways when we resize that window. And if they're not right now, they should be. So I'm thinking we need to separate how this works a little bit. All right, so let's get a fix me in here, right? While I think this through. So let's see, render target attachment source default. So this source should not do a lookup store of the texture until it is ready to be used. This is because render passes graphs should not be bound to a window, yet might need its attachment. So this should look up whatever window, surface, etc. is currently being targeted and use that to perform the lookup when it is needed. Or at the time it is needed, I guess we should say. So I think that makes sense. All right. Well, it looks like we're about to have an ad break, which is good, because I need a minute to think anyway. So for those of you who are new to the channel, we have ads served to us once every 30 minutes for up to 90 seconds on Twitch. So we just pause the stream across the board so that nobody misses any content. Speaking of which, there we are. So we'll just give the ads time to run through, and then we'll continue. Handling some fairly low-level stuff tonight. And the irony is we haven't even gotten to the Vulkan plugin yet. We're just trying to like offshoot some of this complexity from the front end into the back end. So we got about 20 seconds left on ads. All right, ads are done. I've missed 195 episodes. I don't think I could follow if I tried. You might be surprised, actually. So there are folks that show up here occasionally in the chat and in YouTube comments and whatnot who started maybe 6 months ago or so, or a year ago or so, and have actually made their way through most of it. You restarted the series last week, yeah. So, yeah, it is possible. People have done it. There are people that are up to date as well. But yeah, I mean, the thing is, like, the first part of the series is relatively speaking pretty quick to get through because it's a tutorial format. That's how this whole thing started, right? But obviously that only goes so far. And so we broke away from the tutorial format and went with live streaming. And we've been doing that now for over a year. And that's actually, it's almost been a year and a half. And so, you know, you don't necessarily have to watch all those live streams. You could probably just skim them at some point, but yeah. Watch the backlog and watch the newest stream. Yeah. Yep, exactly. At some point I am going to be putting together a guide that will sort of hopefully make that a little bit easier to digest. I just haven't had the time to work on it. It's like, do I work on that or do I work on the engine? It's hard to kind of do both. So yeah, double-ended queue, exactly, yeah. Let's see. How long did it take you to learn Vulkan? Oh, I think my power just took a poop. That's pretty neat. Hope it didn't take my internet with it. Yay for battery backups. Except my printer's having a hissy fit over there now. That's cool. All right, it looks like I'm still in line though, so I think we're good to go. Yeah, all right. Yay for battery backups. Awesome. All right, so how long did it take you to learn Vulkan? So I went back and forth between OpenGL and Vulkan a bunch of times, actually, because it was like one of those things where I was just like, yeah, I need to bite the bullet, but next project. Yeah, I need to bite the bullet, but next project. By the time I actually sat down to start to learn it, from the time I started to learn it till the time I could actually use it for even something small was probably about 6 months. But that's because, there was lots of, I thought I understood how something worked and I was wrong about that and then had to go refactor, that kind of thing. And generally when you're learning something as complex as Vulkan, you write a renderer, you throw it out. You write another renderer, you throw it out. You read the spec in between each time, you look at tutorials, you look at documentation, but you try to break away from tutorials as relatively early once you get the basics, right? And it turns into just looking at examples of code. So the ones out there by Sasha Willems. I looked at the Unreal Engine source a lot just to kind of see how some of those things were used to understand their usage. And then, when it came time to sort of start writing my own Vulkan implementation, a lot of those things made sense because I did that. But yeah, it was probably 6 months plus when I actually seriously started using it. Which sounds like a long time, but also bear in mind I'm doing this stuff half part-time, right? So if I were doing it full-time, I probably could have picked it up in like a month or two. But yeah, hope that makes sense. All good with the stream. Perfect. Okay, cool. I'm glad it didn't shut down because I have a battery backup for this, and I also have a separate one for my internet over there. So I'm glad that all that's working as intended. You have a bunch of OpenGL stuff so far, but you might learn Vulkan sometime. It's worth it because once you learn Vulkan, once you learn how all that stuff works under the hood, it makes the OpenGL stuff make a lot more sense, believe it or not. So, write your own Vulkan or Direct3D12 implementation, scrap it and write another, then another. Exactly, yep. Iteration is the best way to learn. Before I took on this project, I'd probably written a dozen Vulkan renderers, right? None of them very serious or very huge, right? But I understood enough about it at that point to take on a project like this. So, thanks for all the info. Yeah, no problem. No problem at all. That's the purpose of the channel. Okay. So let's just see where all these textures are used, right? Because we have these attachment textures. So that's the render target create. All right, we commented that one out. Okay, so render target attachment. I'm pretty sure we have to pass this off to the back end at some point. And that is really where all this indexing stuff should happen. So we have all of these passes. This is all render target stuff. Okay, so this has got to be... So in the renderer front end, when we are creating a render pass, let's see, we pass the config, we have the render target count, which is now no longer a thing. Right, so I'm almost thinking we need like an internal representation of the render pass as well, which I don't believe we actually have. We have, let's see, render pass create in the back end. So out render pass. So that's got to have. It does have internal data. Right, so that's stood up by the plugin. So we probably ought to be a little bit more explicit with our typing here, I guess. We could maybe pull that off. And then let's take a look in the back end for render target creation. So we have the attachments themselves. The attachments now only have one texture, which makes sense. Actually, I don't think they have any textures at all. Max number of attachment views. Okay. So when we're creating the frame buffer, now that I'm thinking about this, like our render target is really nothing more than a frame buffer, right? And a texture. That's really all that is. And so I'm thinking like maybe we should expose the frame buffer to the front end. And that would make a lot of this a lot simpler. Right? So if we have it does take in the render pass, which it needs. It basically needs a compatible render pass. Attachment count, attachments. This is where the texture hookup is. Houdini Hacker, thank you for the follow. Appreciate that. Welcome. Let's see. You have about 5 Direct3D 12 implementations laying around on your computer? Yeah, nice. That's probably what I'm going to do when I start researching it. You're going to start the 6th tomorrow. Nice. Coffee Lava, thank you for the hydrate. Redeem, appreciate that. So now I'm thinking, like, maybe I just do away with this whole render target thing. And just use like straight up frame buffers. Right? And maybe we create a front end structure. Because most of this stuff actually comes from, well, wait a minute though. So our attachments. This is a little bit weird the way that this works, but that's Vulkan for you. Do we... So here we're looping through the attachments. Picking out the attachment views. It looks like we're just jamming those into an array and then... For some reason, we're storing this in the out render target as well. Why do we need to do that, though? Trying to think of what the... So we're literally taking this array that we're passing in, and we're copying the contents of it into this. And I cannot think for the life of me why I would have done that. Unless I was trying to work around some problem that, like, disappeared in the meantime. Okay, so maybe we need to take a step back from this and just say maybe we need to get rid of render targets and just deal with frame buffers and images. Because that's ultimately all it is, right? That's all an attachment is, right? Is just a view and an image, right? Which the view is only something that Vulkan knows about anyway. So really it's just a texture. Well, and we do have this render pass association, which is a little bit weird. But nothing I can't get around. Decouple the render pass from the render target? Yeah. Dynamic rendering would be handy to have. And this is one of those weird things about Vulkan that I really, really dislike. Is the fact that you have to have a render pass associated with your frame buffer. It's like, but why though? Right? Like, yes, I could use dynamic rendering. The problem with that is not all hardware supports it. It's pretty limited, actually. Like on mobile, forget it. So unfortunately, we do have that coupling that we have to kind of keep. But I don't really need that anywhere else. I wonder if there's a way that I can abstract that purely to the back end and not have the front end even worry about it. Like maybe we have some sort of call to like bind a render pass for configuration. Beware with how you do this on the front end because it's Vulkan specific. Exactly. And see, this is like what I'm trying to eliminate, right? So half of what I'm trying to refactor here is because there's Vulkan crap that is leaked out to the front end. So like this layer index, for example, or the number of frames that we have. Like that's all Vulkan specific stuff that doesn't need to be known by the front end, right? The front end shouldn't care about that. Layer index. Well, layer index is for layered textures, technically. So that's for like rendering to a cube map, for example. So I guess that's kind of a bad example, but like this render pass coupling is purely a Vulkan thing. I highly doubt DirectX is going to make us do that. So I'm just trying to get away from like the front end having to do this stuff. The front end can know about a frame buffer, and it can know about the target texture, right? Like even in OpenGL, you have a concept of a frame buffer. Like you have the default frame buffer, and then you have a texture that you bind to that, which is technically bound to it like a slot, right? Which has its own issues, but that's neither here or there. Render passes on Direct3D 12 were not a thing until recently. Yeah, I probably should start reading up on DirectX 12 just to get to like wrap my head around what I'm going to need in terms of that kind of stuff. Because yeah, I haven't touched that API at all. I've only ever used 11, right? So part of the challenge of doing that is I'm going to be learning that API while I'm doing it. And they suck, no subpasses even. Are they required though? Like, do you have to use them, or can you get around it? They're not required. Yeah, so I'd probably just not use it unless there's some reason to. Completely optional. Yeah, so if it's completely optional and it sucks, then I won't be doing that. Especially if it's like one of those things that's also not widely supported. Direct3D 12 is dynamic by default, yeah. I wonder if they added that in there to like try and make it work like the Vulkan way, more or less. Although I'll admit I don't really use subpasses. I don't really use subpasses here either. Not really. I could, I suppose, but like enhanced barriers, yeah. I remember, yeah, this coupling here is what tripped me up a long time ago too. And that's the reason half of this stuff exists the way it does. And I really want to get around that because I hate it. I didn't think I was going to run into this soon, actually. Alright, so if I start thinking this out. Let's do a frame buffer create, right? So we'll have the renderer plugin. Which is actually not even called that anymore, so I'm gonna have to fix that. Attachment count. So I do need to know what attachments I need, right? So this render target attachment, that's not going to work because it doesn't like this line. The render target attachment. Why did it? I want the struct, you dingus, not that. Okay. So render target. So we have a render target, which is an attachment count, an array of attachments, and a frame buffer. I mean, I guess that kind of does make sense, right? Like, but then the render target itself, the render target attachment, I guess I should say, has a type, a source, a load operation, a store operation, right? And this is more Vulkan crap. We could probably see if we should, like, maybe offload some of that stuff too. And then it has a pointer to a texture. So, I mean, technically speaking, I could just do away with this struct and keep it. Well, no, not really. It's essentially Vulkan resource barriers. Yeah, that makes sense. So I wonder if we should just have something that's like, I actually do think the structure of this makes sense. I'm not sure I want to nuke it. The only thing that I might want to do away with is the actual texture itself. Like the pointer to the texture itself, I think is probably something I should do away with. Right? We should probably say, okay, what's the type, what's the source? And at that point, look up a texture. I don't know if there is a way that I can actually decouple this from the render pass on the front end because of this requirement here when you actually create the frame buffer. I'm trying to think of a way around it. Should I just... Because the problem is if I just do a frame buffer create, right? That's going to have to get that render pass from somewhere. Just like this does. Your render target implementation is simply an array of 9 textures. 8 for color and 1 for depth stencil. Why would you have so many textures though? Because most of the time you're not going to need that many, right? Oh, deferred. Oh, that's okay. That's completely different. Yeah, okay. I forgot you were working with a deferred pipeline. Yep. When I suppose that's the other thing I have to think about too, right? Is like 8 for color is the limit for Direct 3D 12. I wouldn't be surprised if that's Vulkan's limit too, to be honest. So the problem with that kind of a setup is like if you hard code that, then you can't actually work with any other sort of pipeline besides deferred, right? So I don't want to make that assumption. I don't want to make any assumptions at the renderer level about how things are going to be attached or used. I mean, I could say I have 8 color textures, right? But like if I don't actually need 8 of those, then why set them up? Mike Rip, thank you for the follow, by the way. Appreciate that. Welcome. So I'm thinking the way that I've got this here actually kind of makes sense. Although having to strip out the views this way is a little bit weird, but so for each attachment, I also wrote this code like a year and a half ago, so I'm having to refresh my memory. Okay. So all it wants is the views as those attachments themselves. Just bind the textures that aren't null in the array. That's true, I suppose. Could also have a counter that tells how many attachments you currently have. Well, I do actually I already kind of do have that, right? I have an attachment count. But yeah, I may have to. I think I'm gonna have to rethink the way that I'm doing. The way that I'm doing these render targets. Because like this. Because I also have to think about the source of where that texture comes from too. Which, realistically speaking, well, the front end could know some details about that, right? It knows it's a texture, right? That texture could be owned by the render graph, or it could be owned by a window. But the problem is there's more than one of those textures, right? This might actually be something that I have to take care of on a texture level too. So what I mean by that is if we go to what is it, renderer types, I think. Really? No. Oh, we have ads. So I'm not going to code anything while ads are running. Got about a minute left on ads. Ads for the lads, exactly. Yeah, so the I don't know if you were here for that when that happened, but the reason it says lads on there is because when I type exclamation point ads in the chat, it looked like lads. Almost done with ads, and then we can continue. Good to see you, by the way, Psycode. Oh, you weren't here for that? Yeah. So if you look, yeah, actually, yeah. It's so whenever I pull up the ad screen, one of the things that it does is it sends exclamation point ads to the chat. And if you look at it, it looks like it says lads. So it just became kind of a meme, right? All right. So ads are dead. Mike Rip, thank you for that. I appreciate that. So the Vim config is actually I wrote up an article here, so I will put that into chat if you're interested in the actual config. It's there for you. I wrote up an article on my website just describing what I use and why, and then there's actually a link to the config in there. Psycode himself is here. Yes, he is. Colt Penny, first time chat, welcome. Hey, are targets the same thing in Vulkan and OpenGL? So when we're talking about render target is really just a conceptual thing. And essentially what it is it's a combination of a frame buffer and a texture, more or less. And so the issue is that Vulkan has this weird requirement that it also has to be bound to a render pass. Technically, it doesn't have to be bound to a specific render pass. It has to be bound to a compatible render pass where a lot of the types of data or the input parameters match what you're actually going to be passing it or rendering it with. And so it just has that really sort of bizarre requirement for that. And due to that, it's kind of complicating what we're trying to do here. Let's see. You're a Vulkan enthusiast, you would say. Nice. Yeah. This is one of my least favorite parts about the API. Is this stupid requirement right there. Hate it. Hate it. And I could use dynamic rendering, yes, but it's not. It's like, it's also, I'd be restricting myself a lot by doing that. Because there's a lot of hardware that doesn't support it. And so I'm just kind of like brainstorming now to like try and think of like a way around this where the front end doesn't have to be aware of it. And, only my sort of internal Vulkan backend code has to worry about that. And so it's like I could do something that's like a bind, right? Like I could say, I'm working against this render pass right now, and that's kind of lame. But that also, technically speaking, makes the front end aware of it as well. So it's not really an ideal situation either. Maybe track the current active render pass. and create the frame buffer on the fly when you bind the render target. Create the render buffer on the fly. That way you just have to expose the render target. Monkey Programmer, thank you for the follow. I tried very long to abstract the render pass from the frame buffer, but every time I ended up needing to keep this connection in the front end as well. It's really unfortunate. Yeah. And I know, like, when I did this initially, I was just like, screw it. I'll just put the render pass in there. I'll pass it for now and I'll figure it out later. And, like, I'm in the middle of a fairly large refactor where I'm trying to, like, get a lot of stuff out of the front end that shouldn't be there in the first place. Like, knowledge of double buffering versus triple buffering, things like that, and image indexes and all that kind of stuff. And this is right in line with that. Where, like, the front end should not give a crap about what render pass is being bound to a render target. And the only way I can think to do it is to have some sort of binding. Unless... Nope. Because the problem is it's got to be a compatible render pass, right? So, it's got to be a render pass that works against the same types of attachments and same number of attachments as what my frame buffer has. And so, like, even if I kept a lookup table of what those were internally, how would I possibly know which one of those it was actually going to be that I could use as sort of a template render pass to just say, well, this is what we're kind of expecting. So, you know, if you run into this, just use this one for now and we'll pass a compatible one in the future. But I don't even know that per se, unless, ooh, wait a minute. Maybe, what if I did something like render pass, like a render pass profile, so to speak, where I just set up render passes internally that take a few known configurations that are going to be common, right? Like maybe we have a render pass that takes only a color attachment, and then we have another render pass that takes only a color attachment with a depth attachment, and then we have one that only takes a depth attachment, and then we have one that takes enough to be like make a G buffer. Those kind of things, right? Maybe we create dummy render passes within the Vulkan backend. We create dummy render passes, and then we say, hey, the attachment layout that we're passing here, does it match one of those dummy render passes? And if so, use that. You said create on the fly because the render pass connection goes on the frame buffer create info. Yeah. I had an iteration of my renderer where I had internal passes and frame buffers that referenced them based on the attachments you use. I wonder if we're saying the same thing, Salty, or not. The compatibility requirement is the root of all evil. Yeah, it really is. It's usually done with samplers and render pass format of sorts. Yeah. Linear min-mag clamp, linear min-mag repeat. Render pass format, probably. Yeah. So I'm wondering, like, if I if I create some well-known render pass formats, or actually, wait a minute, I don't even need to do that. When I create the render pass, I could just add that into the table and maybe keep with it its list of attachments, right, in the order and so forth. And then just do an internal lookup on that. Right, because the render pass would have to be created before our render target's created anyway. So we should already have that information that we would need. So if I at the time of render pass creation, cache that off internally, then I could just say, okay, well, grab one that's got a layout similar to this and use it, right? And then it's compatible. And then it doesn't matter. And that's kind of, well, could I not make those render passes on demand? Why would you need them up front? That's a good point too, actually. I could just create a dummy render pass that meets this criteria. That's actually not a bad idea either. Because then the one that comes in behind it's only got to be compatible. I wonder if I could create it long enough to like... I wonder if I create a dummy render pass and then create the frame buffer and then throw the dummy render pass away. If it would just completely like poop itself. That's actually a really good point. Because then I don't even have to maintain a lookup table, right? Lightly Abridged, thank you for the Prime sub. I appreciate that. And the follow. Thank you very much. Appreciate the support. So... Oh, I didn't want this one. I want the Vulkan one. Right, so we're going through and doing the same thing here. Like we're creating our attachments. So maybe we just set up like a very lightweight version of this. Actually, I might just be able to use this. Maybe that's the way to go. Why not, right? It's got to be compatible. We have all the information that we need from the attachments themselves. Let's see. So the render pass config. Right? Has... I don't know if this stuff matters. I don't think it does. I think the only thing that have to be compatible is the render targets themselves, I believe. And maybe... No, I don't even think the clear flags matter. Maybe this stuff matters. Render target count, and then render target config. Which again is just the same thing as what we have already in our attachments themselves. I'm not seeing a reason why this wouldn't work. But you never know. Vulkan, right? So I think what I'm going to do is, before I forget exactly where I am in this rabbit hole, let's do a to-do here. Because of, of Vulkan's insistence on tightly coupling render passes to frame buffers, creates a dummy render pass based on the attachment config we already have here. This would currently need to pass in a render pass from the front end, at least in theory. The problem with this is it's going to be a while before I can actually test to see if this works, because I've got so many other broken things that I need to fix. So I might put a pin in this and come back to it. But I think that's going to be the solution. How will you handle your pipelines? In what context? I mean, pipelines are already kind of being handled already, so I don't think that's going to be an issue. Maybe it's better to build a quick side project to test this idea. Might be. Need to provide your render pass when creating them. That's a good point, because that's also tightly coupled. How did I do that? I don't remember. So I think my pipeline config actually contains. Yep. My pipeline config contains one too. So that's another spot. I forgot about that. That's another spot where it's tightly coupled. That's annoying. So I might be able to... I might be able to... Eclipse GT, by the way, thank you for the follow. Appreciate that. I wonder if there is... I really don't understand why they required, like, such tight coupling of some of this stuff. Let's see. Yeah, so we have the render pass right here in our pipeline config. Which right now, it's actually... So this is another... this is another thing I've actually given some thought to offline. So right now our pipelines are tied to a shader, right? And we might have multiple pipelines for shader depending on what, you know, what our needs are in terms of state, dynamic state, and all that stuff. So right now they're tied to a shader, and they probably shouldn't be, right? Because the Vulkan pipeline really is just about, it's not just shader specific. Like, you have your attribute layout, you have all that stuff, right? And so I'm thinking at some point I might separate that out too. Made that same face so many times. Yeah. Yeah. It's really annoying how coupled some of this stuff is. Like, these are the parts of the Vulkan API that I absolutely deplore. Because there's no reason. And clearly they could fix it, because they fixed it later on in later versions. You have to use dynamic state, right? Which part of me wants to really just go, screw it, let's just use the dynamic state, and for anything else we'll just make them fall back to OpenGL or something, right? But that feels crappy. Yeah, blend col, etc. Yeah, exactly. They could just make this depend on a render pass format, not the render pass itself. Yeah. Yeah, and that's the thing, right? Like, because that's all it really wants. It wants compatibility, which means it doesn't really need the pass itself. It just needs things that are compatible with it. Yeah, exactly. They're clearly only worried about the format. Exactly. So why couldn't it just take that? And unfortunately, there's no way in the API to make it do that. So yeah, this is going to be another... All right, goes right here. The Vulkan shader itself has a render pass. So our render pass is tied to our shader too. Forgot about that too. Because that code's probably 2 or 3 years old. So when we create the shader... Wow, where did it go just then? Undo that. Shader config. Sure, okay. Yeah, so whenever we create our shader, we also have to pass in a render pass for that, which is super shitty. How are we getting around that like right now, actually? Because I actually don't... So when we do shader system create, that takes in a render pass. Like, man, this coupling goes hard. Because this shouldn't exist either. But again, I was forced to because Vulkan. I'm getting lucky because everywhere where I'm creating a shader is also the same place where I'm like holding onto render pass information. Which is like our individual passes for our render graph, for example. Also have the internal render pass information that they need, as well as the shader, right? And that's how all the binding stuff is hooked up. So I got lucky because of the way that I happened to structure it. Leprechaun, hey, how's it going? Good to see you. Yes, I am also streaming on Twitch. Yeah. Let's see. Tried to build my game engine project and it said I had errors even though I didn't. It was building on episode 1. Can you help me? So one thing you could do is you could try asking on the Discord server. And I could take a look at it there, but I mean, do you have it like up on a repo or something, or like what errors are you getting, etc.? All right. All right. I don't think I'm going to tackle this render pass problem as part of this yet. But what I am going to do is I am going to put a to-do in here. Let's see. Let's go decouple render pass from shader pipeline and frame buffer render target. That's definitely a must going forward for sure. The only thing I can think is creating dummy bare bones compatible render pass for common attachment formats and use that to creating frame buffers and pipelines. Yeah, so that's kind of what I was talking about before, but then I was like, what is it? Salty actually brought up is like, well, why don't you just make them on the fly? Which actually makes a lot of sense, right? So like I could literally just make one based off of, because I already have most of what I need at the time of creation, right? So I have my attachment config. I know how many attachments I have. I know what order they're in and what type they are. So I could literally just say, okay, well, based off of this, just create a dummy render pass and then use that for the frame buffer and then throw away the render pass, right? Because whatever comes in behind it will have to be compatible with it. The pipeline, I think, is going to be a little bit more complicated than that, but not much, I don't think. But that's kind of my plan. That's why I put this guy here. So that's exactly what I'm going to try. I mean, if the reason for not using dynamic rendering extension is compatibility with phones, I don't think you should worry about it too much. All right, we have ads, and then I'll tackle that when we come back. The engine doesn't currently have support for Android. You're right about that, and I'm going to come back to that actually. Because I think, let me actually while ads are running, let me look something up. Almost done with ads. Okay, ads are done. So one of the things that I was looking at, because I know at one point this was an issue. I don't know if it still is. We rely on Molten VK for macOS compatibility, right? Or to be able to run on that platform. And at one point, that was flat out not supported. But just looking at the Molten VK project, I found an issue in here. Actually, I'll just pull it down here. Where somebody was talking about dynamic rendering on M2 seg faults, which means to me that they might have put it in. But that was one of my primary reasons that I couldn't do it, is because it flat out was not supported at one point on this. Maybe now it is. And so if it is, then maybe that is a direction I can go. I have to do a little bit more research on, let's see, enable Vulkan. Yeah, so it looks like this person was able to actually do it, and it was working on an M2 anyway. So that tells me at least somewhat recently it works. So I'm thinking maybe I need to re-look into that, right? Because if I can make it work with dynamic state and there's not too much issue in terms of like flat out locking people out because of what hardware they have or whatnot, maybe that's going to be the way to go. May Saka with Party of 19, the raid. Thank you very much. I appreciate that. What did you get up to on stream tonight? Molten VK runs on 1.2. Exactly. That's as dynamic rendering. Yep. But that's still, the extension's still available. So I have to look into that. I'll have to try it. So let me give a quick intro to all the folks that are here from the raid. First of all, welcome raiders. What we are doing here is we are building a game engine from scratch. The game engine is built in C, and it's using Vulkan as our initial rendering backend. It is cross-platform compatible, so it runs on Windows, Linux, and Mac OS at the moment. So this project's been going for about 3 years. It started off as a YouTube tutorial series, and we morphed formats a few times, trying a few things out, seeing what works, and eventually we sort of landed on this live stream format. And so the engine is open source. It is royalty free, so all of the source is available on GitHub. There is a link to that. I'll drop that in chat. And I should point out that is Apache 2.0 license, which basically means you can use it for personal or commercial use. Does not matter. All that I ask is that you say that you used Kohi. That's literally it. There will never be any sort of royalties or licensing fees of any kind. This engine will always be open source, always 100% free, never paywalled. And so I mentioned Vulkan as our initial rendering backend. We do have plans to support Direct 3D and Metal at a minimum. But for right now, Vulkan is the first one that we're implementing because it gets us the furthest, the most mileage, right? So I am actually currently running on Linux, right? So We are doing our development on Linux at the moment, but it does run on Windows and Mac OS as well. We do have a Discord server as well. It's got about 900 people on there. And then we've got some other links to stuff on here. And then of course we've got the live stream down here at the bottom where you can see me. Yay, Inception. So that is more or less what we are working on. Thank you guys for the follows, by the way. And we are in the middle of a fairly large refactor right now, trying to bat away some specific issues that Vulkan causes that have sort of leaked out into our front end. And we're trying to bat those back away into our rendering back end, which is all the Vulkan stuff. So we have a front end and a back end. Our front end is basically what the engine itself is responsible for communicating with, and it's renderer API agnostic. And then we have a back end that is where all the renderer API stuff exists, like Vulkan or Metal or whatnot. So let's see. I fixed resizing in my engine. I've been using the Vulkan API. Then I read way too much about ray tracing features. Yeah, I've steered clear of ray tracing just because I know what kind of a rabbit hole that's going to be when I eventually do hit it, for sure. So yeah, that's going to be quite the feature to implement, I think, once we get there. But yeah, we have developed this whole thing pretty much from scratch. There are a couple small things that we're using, utilities that we've used, like we used some of the STB libraries to load images and fonts and things like that. But other than that, we've done everything from scratch. So we have a roadmap / to-do list here that's got a whole bunch of things that we've worked on. Everything that's got an X on it is stuff that we've already completed. Stuff that's blank is obviously still in progress. I'm just going to scroll through this really fast because the list is really long, but you can see that we've got decent coverage of some things. And so we still have a lot of to-do items to go. We are looking at starting on making a game with this sometime very, very soon. Part of this refactor right now is to sort of batten down the hatches on some things and make some of the APIs a little bit easier to use from a development perspective, and get some of the more to-do hacky stuff out of the code base, right? So that's kind of what we're working on right now. First time chat, get failed. Thank you for joining us, by the way. Thanks for the videos and the project. I got motivated to finally start learning programming about 5 months ago. That is awesome. I'm glad to hear that. Welcome to the fray. Trying to make my own game engine in C, struggling, but I've learned so much, and creating my own memory debugger with no reference, and the only knowledge I gained working without testing was a crazy feeling. Yeah, it's really it's super rewarding to work on, right? It's especially when you get stuff working and you see stuff drawing to the screen. It's very, very rewarding, I think. So I'm glad you've joined in. I'm glad you're having fun, and I'm glad you're following along and enjoying the project. The whole purpose of it was to be an educational resource, and it was more or less the resource I kind of wish that I had when I was learning this stuff. So. With all of that said, unfortunately, I am coming to the end of the stream for tonight, just because I do have to get up in the morning and work, and so I can't stream super late or anything. So what I'm going to do is I'm currently working on a feature branch. So this feature branch is horribly broken. I don't recommend pulling it. But in the if you guys want to see like a sort of semi-current build of the engine, I would say you probably are going to want to pull down the 0.7 branch, which is this guy right here. And so this one is, got, here's a couple of screenshots. I can't run it right now because I'm in the middle of a refactor. But here's a couple of screenshots of what the engine actually looks like. We recently put in a PBR, cascading shadow maps. We've got some issues. We've got some shadow acting issues to work out. In fact, some of that's been worked out. I need to update these screenshots. But, I would recommend if you guys are going to take a look at the project, check out the 0.7 branch as opposed to the main branch. There is a little bit of documentation in here on how to, set it up, build it, that kind of thing. So hopefully all of that works well for you guys. But what I'm going to do is I'm actually going to check all this stuff into our feature reorg branch, which actually has, a whole... oh, I don't want to save that. Okay. It has a whole bunch of changes that we have done. So, for example, status, right? Like this is just part of the scope of like what we've been refactoring, right? So let me get this pushed up. We'll say work in progress. Vulkan plugin refactor. I should also mention that the architecture for this engine is plugin based. So the renderer is a plugin. The audio system is a plugin. The UI system is a plugin. And so there's core functionality and then there's plugins, right? And the reason we did that is because you can add and remove features as you want them and use what you want and don't use what you don't want to use, right? So that's kind of the whole goal here. All right, with all that said, I do have to end, so let me look for a channel to raid really fast. If you guys haven't already, I would encourage you to follow me here and on the YouTube channel that I have as well. I'll drop my socials here in chat so you guys have that. Let me see. Unfortunately, like I said, I feel kind of bad because it's like you guys just got here and I'm already having to run, but unfortunately that's the way it is, right? Let's see. Who do we have? I'm just looking for somebody to raid really fast. I don't really want... You know what? I'm going to do something a little bit different because I think it's a really good cause. So we are going to raid Alveus Sanctuary tonight. And I know it's not dev related, but it is a non-profit animal sanctuary that is run here on Twitch. And I think it's a really good cause and I'd like to support it whenever I can. So that is who we're going to raid tonight. Thank you guys for all the follows. Thank you for interacting with me here. And we will see you guys on the next time we stream. And make a little bit more progress on this refactor. Hopefully get this thing tied up somewhat soon so that we can actually move on to adding some new features. But yeah, anyways, guys, that's going to do it for me tonight. Thank you so much for being here, and I will see you guys later.